Okay friends, in this video we are going to do a very interesting exploration, and that we have to try to answer the questions of how many rational numbers exist between any two given rational numbers. So let's try to understand this using an example. Now we are kind of given how many rational numbers are there between 3 by 10, that is shown over here, and 7 by 10. Now let's try to think through this problem. 3 by 10 and 7 by 10. What lies between 3 by 10 and 7 by 10? And if you follow the logic of us having a number line, let's say, and we have 0, and then let's say this is 1, and we divide this into 10 parts. Let's just say this is, how many parts do we have? Okay, I think close to 10 parts is what? 1, 2, 3, 4, 5, 6, 7, 8, 9. Maybe I need to just locate the number 1 over here. So this is my 1, and let me get rid of this one. Okay, so what we have done is we have located 10 parts. Now 3 by 7 is, so this is 0 by 7, but this is 0 by 10, this is 1 by 10, this one is 1 by 10, then we have 2 by 10, and this is 3 by 10. And then we move ahead, 7 by 10, so 7, so 3, this is 4, 5, 6, and 7. So this point over here is 7 by 10, and 1 of course can be represented as 10 by 10. Okay, so I mean, if you look at this representation, how many rational numbers can you see? So you will say, yeah, we can see 4 by 10, 5 by 10, 6 by 10. Straightforward answer. There are 3 rational numbers between 3 by 10 and 7 by 10. But wait a minute, let's think a little bit further. Can I write 3 by 10 as 30 by 100, multiplying both the numerator and denominator by 10? And we can also write 7 by 10 as 70 by 100. So if you look at it, what has happened over here, that we have actually multiplied this distance between 0 to 1 in 100 parts instead of 10 parts. And therefore, we have now more choice of numbers, which means I have to find out the rational numbers between 30 by 100 and 70 by 100. So if we follow the same logic, you can start with 31 by 100, 32 by 100, and so on all the way you go till 69 by 100. Okay, so we can say that all these numbers, that is 39 additional numbers in the form of p by q, that is 31 by 100, 32 by 100, and all the way up to 69 by 100, they also lie between 3 by 10 and 7 by 10. So far so good. Okay, so we have more numbers than what we think. What happens if we were to go even further and we were to say that, hey, I could also write 3 by 10 as 300 by 1000 and 700 by 1000? It's the same, right? These are equivalent fractions, if you remember that concept of equivalent fractions. So 3 by 10 and 300 by 1000 is same. 3 by 10 is just the simplest form. So now all of a sudden we have even more choice of trying to find out rational numbers between 300 by 1000 and 700 by 1000. And the way in which we progress through this is we say we have 301 by 1000, 302 by 1000, and so on all the way to 699 by 1000. All these numbers, they also lie between 3 by 10 and 7 by 10, and you would be, if you were to count how many of these numbers are, they are actually 3999 such numbers. Well, you can extend this logic further. You can also write it as 3000 divided by 10,000 and so on, which means if you want to get an intuitive feeling, there is really no limit into the number of parts that you can divide the distance from 0 to 1 into, right? And therefore, it kind of brings us to the conclusion that between any two rational numbers, there lie infinite rational numbers. So that is the key result to take away from this discussion. Between any two rational numbers, there lie infinite rational numbers. A very key result. And in the next couple of videos, we will look at how do we find these additional rational numbers between any two given rational numbers. Of course, you already found out one method here which I've shown, and we'll explore a couple more in the coming videos.